Welcome to this is going to be failover with a company in 2 locations using static routes and secondary IPs. So we've got this company in LA. It's in LA and Tampa. Now normally LA is the headquarters. People are there. Tampa is a failover site, so it's like you could call it a cold site or a warm site. Normally this just sits kind of empty. The web servers are there. You've got web servers in both places, but normally the traffic on the internet is going to be flowing in this direction to get to the website, right? So what we want to do here is we've got a normal static route connection, just a default route going to our ISP. And so this is our edge router. That's us, controlled by us. And this router right here called ISP Edge West will be the edge for, you could call it Cogent, Verizon, Time Warner, whatever you want. And we're not running any BGP between us and these guys. It's just going to be a static route. And same thing for Tampa. This is just going to be a static route, static default route pointed up. Nothing too crazy. And that's because maybe your boss doesn't want to run BGP to the other side. You know, maybe your guys don't necessarily know BGP that well, but you definitely know static routes, at least we hope. Now on the ISP side, they've got OSPF everywhere because that's their IGP to let them get connectivity. And then I popped BGP AS666 on all 4 of these as well. Okay. So normally traffic will flow this way. And what we want to accomplish is if there's an earthquake, if there's a massive disaster and this gets taken out, what we want to do is we want to be able to call our ISP, assuming we still have cell service, but we want to call them up and say, hey, we want to fail over all of our incoming traffic to Tampa. Okay? So what's happening here is looking from the ISP side, they've got a route, static route pointed here. Their static route says if you want to get to 64.81 .7.192. If you want to get to that /26, you're going to hit the next hop of this guy. Okay. So if you want to get here, these addresses are also given to you by the ISP, so you had to buy these. So if you want to get to 64.81.7.192/26, so those 64 addresses, or 64 addresses, then you're going to hit a next hop of that guy. And then what the ISP is going to do is he's going to type in redistribute static and pop this into BGP. And after he redistributes into BGP, who's going to know about our network here? Should be everyone, right?
Right.
Right. So the whole internet knows how to get to that IP. So if you're running a web server and you've got DNS, you know, CNN.com or whatever, when they type in CNN.com, they're able to hit your company's website, not a problem.
Right.
Right. Now if we take that one step further, if the ISP nukes this route, then our site disappears from the internet, right? So if the route's in there, the internet sees us. If the route is gone, the internet won't see us.
Makes sense.
Yeah. So normally, that IP route is just on that router right there, ISP Edge West, and then that information propagates through the rest of the network. So first of all, let's set up, because I think I nuked the configs everywhere. Oh, not everywhere, but we're going to need to set up stuff on that guy for sure. ISP Edge West, ISP Edge East, Tampa, and probably the web servers there. But we'll take it one step at a time, because I know if you're just starting off looking at all these numbers and links, your brain probably just blew up. So we'll just concentrate here. And one trick is, you can, if you printed this out, you could use like index cards to cover this up, or whatever helps you just focus in on the particular area that you are configuring. I know other people, what they do is they fold the piece of paper. I mean, that's like the low-tech way of doing it, right? Just fold the piece of paper in half, and you get that. Just ignore that part while you configure the left part. Okay, so first of all, we want to make sure we have full connectivity inside of the ISP, because we're now going to pretend we're the ISP. We're going to go onto ISP Edge West, so look at your diagram there to follow along. And of course, looking at the names of the routers, you can see there's a big chance of foobar here, because there's ISP Edge East, ISP Edge West, ISP Core, Megacorp Tampa, Megacorp LAX, Megacorp Web 1, Web 2. So it's very easy to click on the wrong tab and mess yourself up. And I say that because while I was doing this, while I was setting up, I did that too. I clicked on the wrong one, started flinging in BGP commands, and it's like, whoops, kind of messed that one up. So first of all, let's go ISP. So I know you're not running the topology right there in front of you right now, but later I'll put this topology up, so you'll be able to play around with it. Yeah, so don't worry about that. But we'll go on ISP Edge West, and we'll just show IP protocols just to make sure we have some stuff here. So BGP is running, OSPF running. I may just luck out here. I'm going to ping all the way to 1.1.1.4, and I can reach the loopback of ISP Edge East. So that's pretty good. Let me just do a ping 255, 255, 255, and I should be able to reach my two buddies 4.80.1.2, so that's Megacorp, and then 999.6, that's ISP Core 1, so I can reach my two neighbors, not a problem. If I show IP route, I'll see O routes, and let's see, I think I might have already put in that static route. I possibly did. Okay, maybe I'm all set up here. But we always want to make sure we verify. Okay, so I've got IP route going to the customer. That's a /26. Reason we went with the /26 is it gives them a decent amount of IPs. And the next hop's going to be 4.80.1.2. So that's Megacorp's router, or edge router. So if this side's set up, I'm pretty sure that ISP Edge East will be good as well. Just do a show run there. So your basic OSPF, throw everything in there, did a passive interface towards the customer. My BGP stuff, not a big deal. I'm basically pairing up with all my neighbors and all the typical update source and next hop self. And then the static route here is going to be 89.12.3.192. That's a /26. Next hop 4.85.1.2. So that's the front IP of the Tampa location. So looks pretty good there. I should be able to, let's see if I can ping from ISP Edge East. Let's see if I can ping 4.80.1.2. May not be able to, because it's possible that the customer isn't set up yet. But looks like the ISP is pretty good at this point. Let's see, I should be able to ping 1113, which is the loopback of ISP Edge West. And if I ping 4.80.1.1, That's the customer-facing IP of ISP Edge West. Okay, any questions so far about how we look on the ISP side? So all we're doing here, through OSPF everywhere, we threw BGP everywhere, and we made static routes pointing to the two locations.
Pretty clear so far.
Yeah, should be pretty easy. So we're not doing any crazy MPLS or anything like that, although we could have, but this is pretty simple. Now in real life, your ISP is going to have like route maps up the wazoo, right? It's not just going to do like IP route or redistribute just like normal. It's going to have like route maps everywhere to constrict stuff. They're going to have like QoS, but for now, I think this is good.
Right.
So we're going to go on the customer side, Megacorp LAX. Megacorp LAX. Show run. Should be very little stuff here. So yeah, we got nothing here. So we're going to run OSPF just so we get some connectivity internally. We're going to throw all of our networks into OSPF. We're going to passive interface towards the ISP, so fast01. And then we're going to do a default information originate always, and that's going to give our web server a way to get out, right? Because we're going to run OSPF on our web server as well.
Right.
And so we should be okay. Oh, and we'll do IP route all zeros. And we're going to point out towards our ISP, which is 480.1.1. And that should be good. So real simple stuff. Default route, point towards our ISP, run OSPF, get connectivity for our web server. Then we'll need to go on our web server. This guy should be really easy because it's just what? Router OSPF1 and just start OSPF.
Right.
Because that default route should fly down towards us. Show IP route. Okay, so we have our OE2 route coming in, all zeros via 64.81.7.193. So that's our edge router. So I think we're okay on the LAX side. Now we're going to go to Tampa. Now looking at your diagram, I know I have a little typo. I'm going to update that, but I've got .193 on both sides. That's obviously not going to work. So the website's going to be 194. So we're going to go to Megacorp Tampa. It's the edge side of Tampa. Show run. You can see the previous commands I did there. So nothing's running on there. Router OSPF1. Throw all of our networks into OSPF. And we'll do a passive interface towards our ISP. And then we'll advertise a default route. And I think we're good for OSPF. And then, of course, don't forget, we've got a default route pointing towards 485.1.1, so to our ISP. Go on Megacorp Web 2. And this is easy peasy, just router OSPF1, network all zeros. And area 0. Okay. Okay, so just as a quick test, from Megacorp Web 2, I'm just going to ping one hop up. We're good. So I can ping my edge router, which I
That's
should.
always a good thing. Yeah.
Yeah, I'd be in trouble if I can't ping my edge router.
Right.
Let's ping the other side of the edge router, which is 4.85.1.2. This should...
Yeah, that's not bueno.
Ooh, oh, look at that. Okay, let's see what's happening there. So just check my IPs, 485.1.2, that's the other side. Let's go on Tampa. Just do a quick idiot check here. 4.85.1.2, I think that was definitely the one I pinged. 4.85.1.2, okay. Show IP route. 89.1, and oh, that's going to be interesting. 89.12.3.190. Okay.
So it's not seeing a DC directly connected? That's weird.
Yeah, it's possible, but let's see. Here's what we could do. This is actually good because then we get into some troubleshooting. Debug IP packet. Let's see what's going on here. Go back to Megacorp Web 2, do a ping. Let's see our debug. So it sees source is 193, that's from the web. Okay, oh, that was different. So source 3.194, that's where it should go. Those are the OSPF hellos. It's almost like, am I even getting them? I don't see.
Check your protocols.
Yeah. So we're running OSPF. Okay, let's see here. Okay, I'm not going crazy. I do have a connected route to fast00 3.190. Whoa, hold on. My address is 3.193. Okay, so the 192 is my network, so that's fine.
Right.
Yeah, that scared me for a second. It's like, what
Oh,
did
right.
I do? So I should see my two connected, and I've got my default route. So let's go on Megacorp Web 2. Show IP protocols. We are running OSPF. Show IP int BR. Just make sure my IPs are correct. 89.12.3.194. So the other side is 193. Looks good to me. I should be able to just ping it direct. I think I did that. Okay, so we could ping direct. Show IP route. Whoa. That's interesting.
It's not redistributing the static, the default,
Yeah, okay.
or advertising it rather. That's interesting.
Yeah, okay. So let's see here. We are running OSPF. That's probably the most bare bones OSPF you can get.
Yeah.
So we go on Megacorp Tampa, show run. Let's see what we got. So we have this IP route, all zeros, 4.85.1.1. We have a passive interface fast01. Okay, so we're popping that link into OSPF, but we're not sending updates out that link. We threw all of our networks into area 0, and we're doing default information originate always.
Even if you didn't have that static route in there, the always on the OSPF should advertise the default route to neighboring routers, right?
Yeah, you would think. Let's see here.
Interesting.
Show IP route. Yeah, I definitely have, I've got my static route in there. Well, let's see. Show IP OSPF neighbor. Oh, okay. That would, okay, that could explain it. I don't have an OSPF neighbor. So let's see about, let me think here. Show IP OSPF interface brief. Let's see what we got here. So on fast01, I'm 4.85. On fast00, I'm 89.12. That's good. Both of us are DR. Okay. Let's go back to Megacorp Web 2. On fast00, oh, you see
Huh.
that? Both sides are
Yeah.
DR.
Interesting.
Now that is crazy, isn't it? Okay, well, we know how to fix that. Clear IP OSPF process. And yes.
I don't think I've ever seen that actually.
Yeah. Oh, I
Huh.
know what I did. So before you came on,
Yeah.
I was just following the diagram and I popped 193 on both sides and I started
Oh,
OSPF. So then what happened is it stuck,
right.
right? So when it sticks like that, you have to clear it out.
Right. Yeah. Okay.
So, well, that was actually pretty cool. So now, after that's all done, show
Didn't see a neighbor
IP
come up though.
OSPF. Yeah, let's see here. I'm
Clear it
gonna,
on the other side, maybe.
yeah, I'm gonna clear it on the other side because the other side's gonna have messed up information as
Right.
well. Okay, let's
Come on.
cross our fingers and see what happens. Of course, we probably could have saved a couple minutes of troubleshooting if I had just done that show IP OSPF neighbor right off the bat.
Right.
But
Hmm.
kind of weird, huh?
Yeah, it is.
All right, nuclear option. No router OSPF1 on both sides. Router OSPF1. Network all zeros.
Was it seeing it like an NBMA or something? You maybe changed it to point, or I don't know. That's
No,
kind of
I didn't
weird.
do that. But show IP OSPF interface brief. Okay, so it's waiting. Cool. Area 0. Do passive interface towards fast01. Default information originate always. All right.
Hmm.
We had correct OSPF on the other side, didn't we? Let's see here. Yeah, well, yeah, we had to
Yeah, but it's
because
just carte blanche. Yeah.
we're getting that guy. Well, let's do this. Debug IP OSPF JSON-C. See what we're getting here. Maybe debug IP OSPF hello. Oh, let's see what we got here. We are getting hello, mismatched hellos.
Yeah. Received
Receive.
40 versus received 10.
Oh
So local
wow,
is 10, received 40. So it's a different media type on the other end.
look at that. That's pretty awesome. So if we do this, show
Yeah.
IP OSPF interface fast00.
Okay.
Okay, so this is 104040.
Yeah.
Go to Tampa. Show IP OSPF interface fast00.
Huh.
What? Okay.
All
That's
right.
we got some gremlins on this one.
Maybe restart the router.
Okay, let's see here. Okay, so Megacorp Tampa received from 89.12.3.194. That is the other side from fast00. Okay, mismatch received. The heck? So just for kicks, we're gonna do this. IP OSPF hello interval 10.
Right.
Go over here. IP OSPF hello interval 10. So that they're the same on both sides. Debug IP OSPF hello. Now let's see what's going on.
Huh.
Okay, let's change our dead interval. Well, actually, let's see.
Yeah,
You
but
change the
it's
hello,
hey.
it
Yeah.
automatically changes the dead.
Right.
Yeah. Show IP OSPF interface fast00. Let's check this out. This is a broadcast.
Yeah. As was the other, right?
I think so.
Yeah.
Broadcast.
And it even says, received 10, configured 10.
Yeah.
That's
Oh
interesting.
man. Okay. Continuing on. Let's go to our edge and see if we could just ping from the edge. Let's 64.81.7.193. Okay. Let's see if we can ping. Let's see, 9996. Okay, so we can ping there. And we can ping there. Let's see if we can ping the other side of ISP Edge West. So 480.11. Yeah, we can ping there. Okay, good.
Interesting.
And we can ping all the way to LAX. So that's good. Now, can we ping to... Okay, that's where it dies out. But at least we can get to the front of Megacorp LAX. So we have some connectivity there.
Right.
Okay. So let's see. Let's do the 30-second trial on Megacorp LAX just to see why it doesn't respond back. Show IP route. It's a default route back, which is really weird, right? So it should get a ping and just fling it right back to ISP Edge West. So we'll do this. Trace 64.81.7.193. And so we can get to 40, we can get to 1.1, which is ISP Edge East. We can get to 99.10. Okay, so we're dying in the core right here. Show IP route. And that kind of makes sense right there if you think about it. The core doesn't know how to get to that 64 and it doesn't know how to get to 89. And the reason is I think we have not done redistribution on the ISP side.
Right.
Right? So the ping goes in, it gets past the edge because the edge knows how to get there. Goes in the core and the core just knows our internal routes.
Right.
So the way we fix that, very easy. Go on ISP Edge West. Just take a quick look at our BGP configuration. BGP, well, let's see. See that? We got redistribute static there. Let's go on ISP Edge East. Got to redistribute static as well. Show IP BGP. So you see that we're getting it just fine. That 89 is 64. Okay, good. Now if we go to ISP Core 2, show IP BGP. Whoa. All right, get nothing from BGP. So we'll do this, show IP BGP summary. Who are we actually neighboring up with? All right, so we're neighboring up with 3 and 1. And we're not neighboring up with .4. It looks like to me.
Yeah, .3 is active.
Yep. And .3 is active. Let's see. .3 is getting to the other side. So
Yeah.
we can ping it. So let's see. Let's take a look here. We're getting a lot of troubleshooting on this one.
I know. Well, it's probably an OSPF route it's seeing then, right?
Yeah, yeah.
Yeah.
So let's see here. .3 remote AS666 update source loopback 0 next top self. Okay. We go over to ISP Edge West. Oh yeah, clear as day. There is no neighbor for .3.
Right.
Okay, router BGP 666, and then we'll do neighbor. Oh, yeah.
Oh.
Let's see, neighbor, we're on ISP neighbor 1113, IM 3, so we're going to 2, right?
Right.
Update source loopback 0, next top self. Go back to ISP core 2. Oh yeah, we got a...
You've already got a neighbor there for 3.3.
Yeah. Oh, and 3 comes up. Good.
Okay.
So we've got 1, we've got 3, and we need to go to .4. So basically all 4 routers in my ISP are neighboring to each other. Do our update source loopback 0. Yeah, we really don't need next top self on that one.
Right.
And then go over to ISP Edge East, show IP BGP summary. See, this guy's 1, 2, and that one just came up. Okay. I think we should be okay now. We're already redistributing, so we may be good. We'll go back to Tampa. Looks like that trace goes all the way. Okay, cool. Awesome. Okay, so basically we have full connectivity to both sides. The internet can reach this web server. We'll pretend that it can reach this web server. There's some funkiness going on this link. So normally they go to Megacorp Web 1 in LA. Life is good. Now we have a failover scenario. Earthquake hits. Now we have to get on our cell phone, call up the ISP, and tell them to move the route so that traffic flows to Tampa. And then we want to put these IP addresses as secondary addresses over here before we do that. Because right now in Tampa, show IP interface brief, we're using the IP addresses assigned to us over here. Reason we have to put these secondary addresses over there is that when we do this failover, traffic's going to come over to Tampa. So now traffic's going to go this way. It's going to hit Megacorp Tampa. But then what's going to happen is Megacorp Tampa is going to try to ping the 64 address, and it's going to bomb out. Right, so that's why we need to take these addresses and kind of do like a brain transplant and pop them over here. That's where the secondary addresses come into play. So let's give it a shot. Pop in our secondary addresses, go to Megacorp Tampa. And the secondary addresses are on the inside interface. So you're going to do IP address 6481.7.193, 255.255.255.192, and then you're going to add in the word secondary to that. Then we're going to go to, well, we can't really go on Megacorp Web 2 because we're having some funkiness there. Now, you may be wondering if that interface in Tampa has 2 IP addresses. How does the internet not get confused at this point? During normal operation. Well, the reason the internet doesn't get confused is if we are on the internet, let's say we go on ISP Edge East, let's say, and you show IP route and you say, how do I get to 64.81.7.193? It's going to say, hey, go towards dot 3, which is ISP Edge West. And the reason for that is that BGP route is coming in. Right? Because secondary addresses don't go into your routing protocols and they don't get advertised out. But you could still hit them if you know the direct path. So we've got these secondary addresses on the right side. We're going to go to Megacorp LAX. We are going to kill this static route. So now we're going to sever the connection to LA. Oh, wrong router. I have to go on the ISP for this. So show run. So this is the ISP tech doing his thing after you give him a call. And so this IP route right here, we are going to select that, do a copy, pop a no in front of there, and we've just killed the connection to Megacorp LA. And so when it redistributes, the redistribution statement is going to go, whoa, wait a minute, I don't have a static route to that anymore. And so the redistribution will die. And we could verify that. You go to ISP Edge East, show IP route. And you can see right there, I got nothing towards 64.81. So now all we do on ISP Edge East, pretty simple. You should be able to recreate that static route. So it's going to be 7.192. 192, okay. And then next hop is going to be 4.85.1.2. Oops, IP route. And so why does this work? This works because we already have a redistribution statement in there. So redistribute static into BGP. So as soon as I make this route, that thing flings over there. Now I can keep the other route on ISP Edge East. That's not a problem. Shouldn't bother anything. And so this is the route I had in there originally to go to Tampa. That's fine. That's no problem. So now let's see if this works. Let's go to ISP Edge West. So show IP route. And we should see a 64, looks like. Yeah, 64, right there. So it's saying I can get to 64.81.7.192, and I'm going to hit .4 for that. So what it's saying now is I'm going to go this way to hit those IPs. It's going to shoot it all the way to Megacorp Tampa. It's going to hit the edge router. That edge router's got this secondary IP that I've transplanted over there. So it's got 2 IP addresses, and that ping should come back. We'll keep our fingers crossed. So we're going to go ping 64.81.7.193. And we got a ping. Crowd goes wild. Of course, there was a heck of a lot of things going on in the middle of that, but I was actually pretty good troubleshooting on a lot of that stuff.
Yeah, it was. That was pretty cool. Still perplexed about Web 2 there, but
I don't know what happened there, but we'll chalk it up for GNS3
could very well
problem.
be.
So Kyle says, what OSPF area should these be in? This was all area 0. So they weren't touching each other. So you missed kind of like the intro here. But that's actually fine because this is being recorded in HD and will be uploaded later. So we have got OSPF running in the ISP. This is all area 0. It's area 0. We've got OSPF running here just to get connectivity in between this company. That's area 0. And we've got it here, and that's area 0.
Sorta.
Okay, yeah, sorta. So Rafik says, but the font is too small. That was the old router gods. This is being recorded, like real recording with Camtasia, so not the crap Google or YouTube's Hangout 480p. This is being recorded in 1080p. So when I upload it, you're going to be able to do the full screen 1080p, and we cross our fingers, then the font will be clear. That's why this is a test, to make sure this actually works.
Now, if we can just get YouTube to stream 1080.
Yeah, that's going to be a while.
Right.
All right. So you can see here, this allows you to get failover without having to run BGP on your network. These are just static routes, just like normal static routes. Now in this case right here, we're doing it a little bit funky because this is a manual failover. You actually have to call up and shoot traffic over there. But for some companies, this is okay. They're fine with being able to fail over in 30 minutes because this is a humongous disaster, right? Earthquakes hit LA. No one's going to expect you to, I think they'll cut you some slack if you come up in 30 minutes, Yeah. And that Tampa site is meant to be kind of like a warm site anyways. It's not an instant failover anyways. So does that make sense with the secondary IPs? I know that Cisco in a lot of places, they basically say don't use secondary IPs, but it's like, okay, if you have the command in there, someone's using it. Someone had to request secondary IPs, so what is it good for? And this is exactly what you would use it for, is a failover scenario. And what's happening here is the web still thinks it's hitting here. It still thinks it's hitting the same IP address that was in LAX. It's just a different route. It's in a different place now.